How's it going, everybody? Ed Ricker here, out at Orthopedics Park in Raleigh, and I have a new quad to show you all. This is a 7-inch bi-blade of a beast FPV quad, and we're going to fly a little bit of medium range with it. I'm looking forward to seeing what I can do with this. Now, it's kind of set up to be a long-range quad, but of course this is DJI FPV. If I can spin it around, we got the DJI air unit in there, so some would say that DJI FPV cannot achieve true long range, but what we're going to do is try and squeeze as much long range out of DJI FPV as possible. So a couple months ago I reviewed the Sector 5 version 3 by HGLRC. It's a great little quad, but it's heavy, and there were a few things that made it feel like it might be better for a long range setup, most notably like the GPS system that was included in it. Well, finally got around to it. This was sitting in my bench for a very long time, and finally got around to extending it with some 7-inch arms that I bought. We have a 2200 milliamp hour 5-cell battery on here. The motors were initially rated, I guess, at 6S, but we're using 5S because of the bigger props, and we might even use a throttle limit to get that even better. But earlier today I shot a little explanation of the different parts and what I did to the Sector 5 version 3 to make it a 7-inch mid-range to long-range quad. So check that out, and then we're gonna go and fly this right after. So here it is, the HGLRC Sector 5 converted to a Sector 7. First of all, let's just get this GoPro 9 out of here. This is how I'm gonna get my sweet 5K footage. It's also how this quad weighs an additional 158 grams. But anyway, when I look at a quad like this, the first thing I see is the bi-blade propellers. These are Gemfan 7042 bi-blade props. Bi-blade is more efficient than tri-blade. Tri-blade has a lot more oomph and bite of the air, which is why you see that most times in freestyle and racing. Bi-blade should get me longer flight times. Right here on the top is a GPS module. This is the M80 GPS module, which was on the old Sector 5 version 3 before I kind of reorganized some things. Reason why I mounted it up here on the top of the GoPro is because it used to be mounted back here, and now that I have a very large RDQ 2200 milliamp hour 5-cell battery, when I have it back here, there was no room for the GPS module to be back here anymore. This GPS module not only tells me the direction where I took off, with a little arrow on the DJI OSD. Also tells me longitude and latitude, height, speed, and also has a GPS rescue function where this will be able to autonomously fly back to the general vicinity of home. Luckily, the Sector 5 had such a long GPS wire harness that I was able just to move it from the back to the front without having to elongate any of the wires. So we have these wires strung behind the GoPro down into the flight controller. The GoPro mount, this is the GoPro 9 mount, which I did print with my 3D printer. The arms were very easy to swap, just 2 screws each. So you had the original 5-inch arms that were about that length. And so then each new arm adds about that much distance, that much reach. The Crossfire Nano I've positioned to the front versus the back. With the old design, it was toward the back here, right behind the DJI air unit antenna. And so I wanted to get everything to the front. Now this is a design for when you're really pushing long range, maybe with analog video. You want to get your Crossfire to the front so that if you start having signal loss with your antenna or something, when you're turning to come back home, you actually gain perhaps a little bit of crossfire signal strength because you're turning and exposing Immortal T in your direction as opposed to having it behind the battery and stuff, which just that act of turning 180 degrees might make you lose signal or drop out or something. So I doubt that crossfire is going to be the issue here. More than likely, DJI FPV video feed is going to go out first before crossfire. Speaking of those antenna, these are now the HGLRC long-range hammer antenna, and they're designed for the air unit. They're MMCX connectors right there to the back, so they connect the same way. Those antenna are using a slightly downscaled version of the mount. The original design was like this, very standard looking, but this is also a little bit heavier, a lot more material associated with this design. I went with this particular design. It's about half the amount of TPU, it seems, and then I just used a little bit of hot glue to stuff those antennae in at the exact angle I wanted to. This one is actually sticking up a little bit higher than the mount would already have, and that's why it's getting a little bit above the battery. The fact that these are much longer gets them above the battery pack and out away from the quad. Again, so if I'm turning to face myself coming back, the battery, the GoPro, some of these things are not going to be blocking the signal to and from these antennae. Now the motors are still the 2305 1900 kV motors. So these are a little bit bigger motors than normal for freestyling on 6S, especially with the slightly higher kV there. Most of my normal freestyle quads are like 1750 kV, 2306 for 6S. But anyway, with these longer blades, what I've decided to do is reduce the 6-cell voltage to 5-cell voltage, and I'm probably also going to use a limiter on my radio to reduce that throttle value even more. That way, hopefully, even though these are relatively high kV motors on a 7-inch bi-blade, I can still get by with some good flight times. And that might be the next thing I might have to change on this, are these motors. I don't really know. That's what I'm going to be testing later on today for flight time and efficiency, and seeing if this is really what I want to do from going on from here. Now, I don't know if you can see in here, I hope you can. That little Crossfire Nano, I actually have zip tied to the frame standoff right there. It used to be zip tied to the frame back here behind this battery pad, which, by the way, I also lengthened. The original battery pad was about half this long, but with this long 2200, I just needed a little bit more material back there to hold on to it. So I bought new battery pads just right off of Amazon and stuck one right there. Next to this Crossfire receiver, we also have a beeper in there, and I've housed it nice and neat, and I really don't want to touch it at the moment, but I'll show you a picture of it right here. And that's what I have in here. It's a ViFly Beacon 2. It's a self-powered beacon, so it is connected to the flight controller, so you can activate it with a beeper switch if you'd like, with your aux switch. However, if this drone falls out of the sky, has a battery ejection, this beeper will continue to beep extremely loud, 105 decibels, for 30 hours. The flight controller and ESC are the same. HGLRC F722 flight controller with a 60 amp ESC. Out come the wires to the LED boards, which are also original from the Sector 5 version 3. The easy thing about this, and I've taped over it so you can't really see, but the solder points for the motor wires, they end here and start here. So the LED plate is the bridge to the flight controller. So that means it was very, very easy to find some motor wires to connect from here to here and lengthen the motor wires, because we have longer arms, we need to cover longer distance for those motor wires. And then those LEDs also connect to a 3-pin harness right there. Again, I had some of those just lying around, so I was able to stuff some longer wires there, and then I just kind of taped these around right there to keep those motor wires and LED wires away from the motors, or away from the props. Now, there could still be a prop strike, and normally I would put some sort of protection here. That is something to consider, and maybe I should try and do that. Maybe I should have thought of that before I taped it up, but whatever. So what's the plan, you might ask? All right, so here is Dorothea Dix Park. This is in Raleigh, North Carolina. What my plan is to take off over here in the park by the very edge of this green area, and then fly this direction to the other end. There are some buildings and some parking lots, but on a Sunday like it is today, there are no offices that are open, so it should be just a bunch of empty parking lots, and then fly over to this direction, to this edge of the park. So we're going to be in the complete confines of the park, and from here to here is about exactly a mile, looking at the legend down here. And then to test, flight time, I'll just trace the edge of the park. All right, so here's what I'm going to do with my goggles. I have my two Omni True RC antenna on the bottom, the two stubbies, and those are replacing the stock DJI FPV antenna for the goggles. And then up here are the left-hand polarized Menace directional antenna, and I have them on the top two RP-SMA adapters, and that way hopefully we're going to get better signal, better penetration, better long range with this FPV system. All right, here we go. We're going to be plugging in. All right, you can kind of see in here, I have the GPS custom OSD items like home point, speed, height, although I'm not sure why it says altitude is already 422 feet while I'm sitting on the ground. Didn't do that before. Maybe once I arm and take off, it'll be okay. Longitude and latitude on the top, satellites 15 upper left. We also have amp draw and battery usage, milliamp hour usage. Home arrow there in the center, upper center. Right now it's just a dashed line that'll turn into an arrow once I take off, and it'll show me the direction of home. Scott Rue?
What's going on? Did you print them out for that to fit a 9?
Yeah.
Nice.
$32 miles an hour.
So right now you're favoring the left side of your patch antenna based off your position.
I'm definitely wobbling a bit.
Well, we can imagine the pid tune is for a 5-inch. Tune would be one thing with the 7-inch.
Oh yeah,
you're gonna have
for
no
sure.
resonance. Like I think your arms are what, 5 mil on that one or 6? Yeah.
Probably 5.
Okay. So like my source one is a 6 mil arm and my HD one is a 8 mil arm, and they went up in thickness to help with resonance because as you have a longer fulcrum, you need a thicker arm so you don't have that kind of like resonating frequency thing.
My amp and milliamp draw is not accurate. It says I've already used 900 milliamps.
So that's not calibrated right.
And
I've noticed
it's
that with
pushing 32 amps, which I also don't know if I believe.
No, no way. Right now, based off of how you're cruising and looking at your thumbstick and the KV of the motor, you are probably sub 10 amps would be my realistic guess.
I know this area very well, so I know that I'm not flying over anything to where if this was to fall out of the sky, it'd be a problem. I've flown at Dorothea Dix about 100 times. 50 megabits still, as long as I maintain a healthy altitude.
And right now you're facing just about the correct direction. Your right patch is doing most of the work.
And here's the big field where a lot of us fly at. There are a lot of picnickers, so I'm kind of actually avoiding that. Looking at DJI transmission rate, megabits drop a little bit as I go over that direction because of the amount of trees that are blocking my head with where the quad is. So I'm not going to go any further to the left over there. There's a huge line of trees. Even though there's no leaves on trees right now because it's winter, still getting some vegetation blockage. 16 satellites, altitude 380 feet, distance 2,000 feet away, 40 mile an hour, travel speed 18.7 volts left, 3.5 minute flight time. 40 miles per hour, that's pretty good. I mean, of course, like a Mavic or a Phantom can hold that for a while too. But with a battery like this in an FPV quad, we're able to hold a pretty decent flight speed and not be taxing this battery. These two patch antennas on my goggles seem to be working really well. Of course, everything has been unobstructed so far anyway, so I don't know if that would be much different with stubbies. But I'm going to reach about 1 mile again and then come back. Okay. 1 mile reached, 5,280 feet. Coming back along the side of Western Boulevard, but not over Western Boulevard. All these buildings are closed and uninhabited. Coming back at a 40 mile an hour cruise, 180 feet altitude, 21 satellites, that's the highest I've seen so far. Almost 7 minutes of flight time here. Now, props are significantly in view with the FPV view here. That might be my only gripe. I'm not used to seeing props like that, but they're wide enough and they're dark. They're black props, so they don't really, they're easy to kind of forget about. They're easy to ignore. If they were like pink or orange, then maybe we'd have to reassess. But I bought black intentionally so that if they do show up in the FPV or the GoPro footage, they're not going to be that distracting. All right, a few things I've learned flying this for 3-pack so far. First of all, the GPS module on top of the GoPro seems to be conflicting with the GPS function in the GoPro. So there's a way to turn off the GPS function through the regional tab in the GoPro settings. And yeah, apparently it was affecting the GPS locks to a degree that I couldn't take off with GPS rescue enabled. Other than that, it's working pretty well. We need to calibrate the amp draw and the battery usage milliamp hour indicator because those are way off. Also probably could use a little bit of a PID tuning because this is tuned for 5-inch. It's jostling around a little bit. Hopefully GoPro Hypersmooth will work. Scott over here, you got some 7-inch too, right?
Yep.
So he was serving as my visual observer for my first flight, which is important when you're testing out a new build. He's got a few 7-inch quads himself.
I've got an Oxymoron, which is a HD1 frame with an analog setup, a 20x20 with some old Emax Eco motors off of an old 5-inch build. And then took an old Source 1 V3, put 7-inch arms on it, and ironically I'm running 6-inch props right now to try and keep them out of the super view because 7-inch props on the non-dead cat arm Source 1 shows up in the video. So we're testing.
You're using what size battery for your 7-inch?
This is a 1550 6S Avonic.
Gotcha. And you were getting how much for flight time?
Roughly 9 minutes.
Okay, so I was getting 9 minutes as well with a 5S 2200 milliamp hour battery. So less cells, but more.
Let's read the watt hours.
Oh, okay, let's read the watt hours. 40.7 watt hours on the 2200s.
34.41 watt hours. So the higher voltage is probably helping a little bit. And the weight. I think this on a scale is about 250 grams. I'm not sure what your 2200 weighs. And a lot of that, I mean, has some truth, but if it weighs more, it's going to affect it. Because the overall weight of the aircraft is going to affect efficiency.
What about these Lumineer antenna do you like?
Mostly form factor. Performance-wise, so far, I haven't been able to tell a huge increase, but I haven't done a proper test. But form factor's great. Like when you throw them in your bag, there's nothing really dangling off. You're worried about breaking. Nine minutes and 30 seconds. Not bad. Not too bad.
All right, the sun has set. We are done. I think we had a good, successful time with the 7-inch. Scott flew some of his 7-inch quads. I flew my new one with DJI FPV. 1.3 miles was my record for distance. And then 9.5 minutes was my record for flight time. So thank you so much for watching, everybody. Thank you for taking an interest in the Sector 5 that I changed to a Sector 7. And hoping to be flying more of this guy in the future, especially in some wilderness areas, maybe high in the mountains. Thanks for watching, everybody. Until next time, happy flying.